In this video, we are going to derive an expression of the maximum vertical distance covered by an object which is executing two-dimensional motion, I mean projectile motion. So in this, we are going to take a special case of projectile motion, which I have already mentioned is the projectile motion at an angle. So let us assume that this is a ground from where we are hitting an object, let's say a football or a ball, at some angle theta. So this is a direction of its initial velocity, so that's by u, and at an angle theta, so at an angle theta with the horizontal. So what will be the trajectory? It will be a parabolic, it will be the two-dimensional motion. So that's why this ball will go to the maximum height from where, and then it will not stop at that point, and then it will return. So if we place our rectangular coordinate system at this point, means our x-axis and y-axis, so we can draw here the initial initial velocity components, right? And you know very well that the one component will be the horizontal component, that must be equals to u cos of theta, okay, which remains constant throughout the motion if you assume there is a no air resistance. And the other component, that is a vertical component, positive. Why? Because that's a vertically upward, so that is u sine theta. Discussing horizontal velocity is not our topic, so that's why I'm going to quickly write the reason you just for reference. So this is a reason, that's why the velocity does not change. So I'm going to show you the this ball position at the different instant of times, and at the same level I have drawn this, and just before hitting the ground, this is a position of the ball. Okay, so as we have seen right now that the horizontal velocity will not change, which will be u cos of theta. But what about vertical velocity? Now, according to our equation, v is equals to u minus gt. So this is a component that is continuously subtracting from the vertical component of velocity. That's why the vertical velocity will decrease with respect to time. And moreover, Earth is pulling this object towards its center. So the force is cannot be ignored. Due to this force, this velocity will uniformly decrease. Okay, so the graph will be a straight line if you draw. So here is a small, and at this point, at the maximum height, this object will not stop because it still have some velocity. But the important point is that our, let's consider it's a final velocity, so vy is 0, because I'm considering it is as our initial that's our final position. And for this question, this is our initial position. Okay, now we are going to apply Suvat equations. Why? Because the condition is satisfied. And what is that condition? Condition is that acceleration must be constant, and that is negative g, so that's a constant. Now to find out the maximum vertical distance, what equation should we apply? We don't have a knowledge of the time, that what is the time taken by the ball, so that's why we are left on by like only one equation out of four. And what is that? So that equation is v square is equals to u square plus 2as. So writing it or converting this equation for the y components motion, so uy square plus 2 y component of acceleration and this maximum distance covered. Let's say this is h, so that's why I'm going to write here h. Okay, now we have to find it, so let's put the values. So 0 square is equals to, what is a uy? It is u sine theta whole square plus 2 into negative g into h. So it is u square sine square theta minus 2gh. Okay, so if we take this negative 2gh on the other side, so it will be a positive. So 2gh is equals to u square sine square theta. Okay, so now the height is equals to, this is an expression that you can directly apply in your paper 1A, which is about MCQs, multiple choice questions, if you are given the initial velocity angle. So this is an expression for the maximum height.